Okay, so the first thing in this lab is you need to make sure you make your Beer's Law solution. So you're not going to make the first test tube. This 8 milliliters, uh, or the first one is just the stock solution that's sitting in the beaker at your lab station. So don't make that test tube. But in one test tube, put 4 milliliters of the stock and 4 milliliters of water. And the second one, 2 and 6, and the third one, 1 and 7. So you'll need to make 3 test tubes. Okay, then you're going to get the SpectraVs hooked up and get it warming up, and you have to calibrate it. So you go to Experiment, Calibrate, Spectrometer 1, and so it should pop up. You're going to put some distilled water in the cuvette, and you're going to let it warm up. Now I'm going to skip it for the sake of this video, but you would let it warm up. And anyway, so you should be doing that, getting your solutions made up. Okay, then anyway, you have to hit finish calibration and then hit OK. Okay, after that happens, you're going to need to put some of the stock solution. That's the stuff in the beaker. So you're going to put some of the stock in the cuvette. So fill the cuvette about 7/8 full with the stock. That's the stuff in the beaker. That's the 0.4 molar. You're going to put that in the cuvette. Now we have to tell it what wavelength of light. So we're going to click on the rainbow. And you're going to click absorbance versus concentration. Now one thing, a Beer's Law plot, the absorbance is only proportional to the concentration when the absorbance is between 1 and 0.2. So with our most concentrated solution, we're going to pick an absorbance by clicking right here on the graph around the 1 mark. Okay, so I clicked right there. I said okay. And it should pop up with the Beer's Law plot. And I have an absorbance slightly over 1, but that's okay. Okay, I'm going to hit the play button. And I still have my 0.4 in there. And once the absorbance is up, I'm going to hit the keep button. I'm going to type in the concentration of 0.4. And I'm going to hit OK. Now I'm getting these concentrations from this right here. The stock solution is 0.4. Okay, then we're going to put the second test tube in, this one right here. It's the 0.2 one. So you would dump out the 0.4, and then you would get the next one that you made and pour it in the cuvette. Okay, make sure you're handling it only by the smooth sides, and put it in the correct way, and wait till the absorbance pops up. And when that pops up, then you can hit the keep button, and you're going to type in 0.2, hit OK, dump that one out, take it out, dump that one out, put the next one in, and wipe it off, make sure it's somewhat clean. Okay, put that in, let the absorbance pop up, and hit the keep button. And this one is around 0.1. If I'm just going off the concentrations, basically I'm cutting the concentration in half every time. So pour that one back. Okay, get the last one that you made, pour it in. Okay, let's see here. Where's my lid? All right, put that one in and let the absorbance pop up. Hit the keep button, and this one is oops, I got to type over here, 0.05, and hit OK. Now, after you get that done, hit the stop button. Okay, now hopefully you have a linear arrangement here, and I mixed mine up super fast. Well, let's see how I did. So you're going to do a linear fit. So you're going to go Analyze, Linear Fit. And there, so I'm off a little bit, but I did it in a hurry. Hopefully yours is a little better than mine. So double click on this dialog box, hit the appearance, make it about 20 font or so, hit OK. And then that'll just make it so you can see the slope. You're going to need that for later. And then what I need you to do is to get the unknown, which is in the flask, the volumetric flask at your table. Now, that stuff has acid in it and extra, so you got to be careful with it. You should have diluted it up to the line. Okay, I made it for you, so, but this is what was in your beaker. I made it for you because it's kind of dangerous and I'm not going to be here. So pour some of the unknown out of the volumetric flask. You might want to invert it a couple times to make sure it's mixed up well. Put that in your cuvette. Put the lid on it. Okay, put it in the machine, and then you can see that an absorbance will pop up. And so anyway, then we're going to click on this button over here that goes Analyze, and it's called Interpolation Calculator. And we're just going to hit Appearance. We're going to make it like 20 font. Hit OK. Hit OK. Drag it and put it down over here. Okay, now something seems a little bit off with my spectra reads. It's kind of fluctuating a little bit, but anyway, now you got this data, so you're going to insert this into your lab report. Now I already inserted it into this Mimeo, and I did this the other day, so this is what you're going to use to do the math with. Now the other day I got a little bit different numbers, so my numbers might not match this exactly, but what you should have is you should have this put in your lab report. And now what you're going to do is you're going to go in and you're going to look at your slope of your Beer's Law plot. So my slope is 2.509, 2.509. I'm going to enter that there. Then I'm going to look at, oh, I got to insert a text box here. I don't know, it's being kind of finicky. So I'm going to look at the concentration, the absorbance of my brass sample. So it was 0.3315. That's right here. Okay, so 0.3315, 0.3315. Okay, I have that down right there. And then what I'm going to do is I'm going to do an A equals A, B, C. So to do that, you're going to need a calculator and maybe some scratch paper, but you can incorporate that right into your Google Doc. There's a place to do it. I thought I made a spot for it. So A equals A, B, C. So you're going to write that down here. So you're going to have, oops, I don't want a line that big. So you're going to have, okay, so you're going to go back to this. All right. So A equals A, B, C. So we have A equals A, B, oops, doggone it. Don't know what I did there. A equals A, B, C. So your absorbance, if you go back and look, my absorbance was 0.3315. So 0.3315 is going to equal AB. That's your slope. So I'm going to go back and get my slope, which is 2.509. So it's going to equal 2.509. And then C is your molarity. So I'm going to solve for C. I'm going to divide both sides by 2.509, divide by 0.2509. And so if I take 0.33, so if I go 0.3315 divided by 2.509, this is my calculator, didn't work, 0.3315 divided by 2.509, I get 0.13. So my concentration, I kind of want my line a little bigger. I don't like it like that. So my concentration is equal to 0.1321. Okay, now that's a molarity. Okay, now we're going to use the volume. So what I did is I took your unknown and I put it in a volumetric flask, and that volume is exactly 100 milliliters because I filled it up to the line on the flask, okay? So now what you're going to do is you're going to use the molarity that you calculated, and you're going to calculate the grams of copper. So you're going to start off with 100 milliliters of solution. Now the molarity that I got is 0.1321, which means there's exactly 0.31321 moles of copper in 1,000 milliliters. That's the molarity. Moles per 1 liter or moles per 1,000 milliliters. So I can plug that number in right here. 0.1321 moles copper over 1,000 milliliters. Now I can just change copper to grams. 1 mole copper, and I'm going to use all the numbers on the periodic table. And so 63.546 grams copper. I'm going to do the math. And so I have 100 times 0.1321 times 63.54 divided by 1,000. Okay, and that equals 0.83. So that equals, let's see here, 0.8394 grams copper. So that's how many grams of copper I had in the rifle shells. So I'm going to do a percent of mass of copper. So to get the percent of copper, I'm going to take the grams of copper, 0.8394 grams copper. I'm going to divide it by the mass of the rifle shells, which I had 1.234. That was at the beginning of my lab. So divided by 1.234 grams brass, because brass is a mixture of copper and zinc, and I'm going to multiply that times 100. So if I do that, I end up with 68%. So my percent copper is equal to 68 point, let's see, 0.02%. All right, that's it for this lab. To clean up, pour the stuff down the drain, rinse it out with a lot of water. There is a little extra acid, although it's been diluted quite a bit in the 100 milliliter flask, so be careful with that. That's it.